Hello friends, and in this video we are going to discuss about the quadratic equation. Now, what is quadratic equation? Everyone might have studied about the factors, factorizations, and the linear equation. In terms of the polynomial, we say that the linear equation is the equation which is of the form ax plus b equal to 0. This is the linear equation with one variable. So if you have a linear equation with two variables, you can have the equation like ax plus by plus c equal to 0. Now if you plot this graphically, then ax plus by equal to 0, this will give you a straight line, and here x is minus b over a. So you will get a line, x is negative, means this one. This is y-axis, and you are getting this line, so this distance is minus b over a. Now if you plot bx plus cy plus this one, ax plus by plus c equal to 0, you will get a straight line. This is the basic idea of linear equation, but we are not dealing with that. We are dealing with the quadratic equation, and the quadratic equation is the equation which has a standard form of ax square plus bx plus c equal to 0. This is also polynomial of degree 2, polynomial of degree 2, and this is called a quadratic equation with one variable. Now we can also have a quadratic equation with two variable, and that goes like ax square plus 2hxy plus by square equal to 0. This is the quadratic equation, also homogeneous quadratic equation with the variable 2, because the variable total order here x square is of order 2, x and y together one part for each become 2 and y square. But now we are only dealing with the quadratic equation x square plus bx plus c equal to 0, and this is our topic, and for that I need to clean my screen. Just give me 10 seconds. So the standard equation is ax square plus bx plus c equal to 0. Now how you can frame a quadratic equation when you have the two values for the x? Suppose let you have a situation where x equal to 3 or x equal to 1 by 7. So in this condition, this is a linear equation. Now you can write this as x minus 3 equals 0, and this is x minus 1 by 7 equal to 0, or 7x minus 1 is equal to 0. If you multiply these two linear equation, then you get a quadratic equation. So 7x minus 1 multiplied with x minus 3, and then you get 7x square minus 21x minus x plus 3 is 0. So 7x square minus 22x plus 3 equals 0. And if you see, this equation is already in the standard form, which is x square plus bx plus c equal to 0. And then you get a is 7, b is minus 22, c is 3. So these are the coefficients of the x square, the middle term, and the constant term. Now you might have studied in the class 8, 9 the basic, like when you have multiplied the binomials x plus a and x plus b, you get a term like x square plus ax plus bx, and then you can write x square a plus bx plus ab. This is also a quadratic equation. Now if b becomes a, and this will become x plus a whole square, so you can get x square plus 2ax plus a square. That is a quadratic equation. Then you get x minus a whole square. This is x square minus 2ax plus a square. This is also a quadratic equation. So all these are quadratic expressions. Like if you make them zero, they'll become quadratic equation. But I mean to say that this is the general idea of how to solve quadratic equation. Then you know that to solve quadratic equations you have been taught. Like suppose if I take any example, like x square minus 7x plus 12 is 0, then you might have been taught to multiply the coefficient of x square with a constant term, and the product you get as 12 because this x square coefficient is 1. Then you have to resolve this 12 into the other factors, like the possible combination of the factors, two set of factors, 1 12, 2 6, 3 4, so that their sum or difference as 12 plus 1, 6 minus 2, 3 plus 4, so their sum or difference becomes the coefficient of the middle term. So here we see 3 and 4 is perfectly fitting the middle. It means that this equation can be written as x square minus 4 plus 3x plus 12 is 0, that is x square minus 4x minus 3x plus 12 is 0. Now it is x minus 4 minus 3x minus 4 is 0. So x minus 4 and x minus 3 is 0. So x is either 4 or 3, and this is the set of value you get. So this is a quadratic equation, but standard form of quadratic equation can be solved by some other methods which I am going to discuss just now. Let me clean my screen. So now here I want to solve this equation. Can I solve? This is another method called as converting. This is the method of perfect square. So when you have this equation x square plus bx plus c is 0, now divide both sides of the equation by 0, because by definition of quadratic equation always a is not equal to 0, and when you divide the expression by something which is non-zero, it means there is no change in the value of the expression. So this becomes x square plus b over ax plus c by a is 0. So we'll write this into this form. So 2 dot ab, because I'm trying to write it as a plus b whole square or a minus b whole square, because only those two terms give you the three terms are the trinomial, because x is like suppose if you have a plus b whole square, a square plus 2ab plus b square. So in this condition here I write 2 dot b upon 2a dot x. I'm not doing anything, I just only written this in the form of the product of 2 times x times something. So 2 times x, and then this is b by a, total cancel. Now I need this b square, so let me keep this c by a on this side. So this positive, it becomes negative. Now I have to add the square of this, so I'll do the same thing on the both sides. So I'll add b square over 4a square. This is also b square over 4a square. So this becomes x plus b by 2a whole square is equal to, if you take the LCM, you will get 4 square, that is b square minus 4ac. So x plus b by 2a is plus minus under root b square minus 4ac upon 4a square. But you see that this 4a square is already a perfect square, so we can write this x plus b by 2a is plus minus under root b square minus 4ac over 2a. So just transform this b by a on this side, this becomes minus b by 2a, having the same denominator will get minus b plus minus under root b square minus 4ac upon 2a. Now using plus and minus, if you separate, then you get the two values of x, and these two values are called the roots of the equations of the quadratic equation. So they are roots of quadratic equation. If I say they are alpha and beta, then I get my alpha as minus b plus under root b square minus 4ac upon 2a, and beta is minus b minus under root b square minus 4ac upon 2a. These two are called the roots of quadratic equation. Now if you just see, one interesting thing is that suppose if you want to find the sum of roots, sum of roots is alpha plus beta. If you add these two, you will get minus 2b over 2a, because plus and minus of square root thing, they will cancel each other. This is minus b upon a. And if you want to find a product of the roots, that is alpha beta, then you get this denominator is just 4a square, but the numerator is coming in the form of a plus b and a minus b. This plus this and this minus this is a square minus b square. So I'll get minus b square minus under root b square minus 4ab whole square. This one eventually gives you b square minus b square plus 4ab over 4a square. That is, this is not b, this is c. So this is also c. 4ac b square cancel. So 4ac over 4a square, that is c over a. So we can write our product alpha beta as c by a. Now look at the standard form of this equation. Since these two equations are same here, now just look at this term. This is b over a, and what is the sum of roots we have found? Minus b over a. This is c over a, and what is the product of roots we have found? This. So I mean to say that if you just try to express this like this, so you get a situation like x square plus b by a. You can write it as x square plus, or what I'm getting, x square b by a. So I can write as x square plus here alpha plus beta, that is minus 2b by a. So I am getting my answer is minus b by a. So I can write this as minus b by a x plus c by a is 0. And just if you see that, you see minus b by a, so at the place of this you can write x square minus alpha plus beta x plus alpha beta equal to 0. Means any quadratic equation, if its coefficient of x square is unity, can be expressed as a quadratic equation x square minus alpha plus beta x plus alpha beta equal to 0. This is called the roots. But here we have one important thing to discuss, that is called this thing, which is b square minus 4ac, because this is the discriminant of the equation b square minus 4ac. This I am going to discuss after cleaning the screen. So if you want to take a look at this, if you want to copy something, you can copy by halting the screen there, and I just need to clean it, and then I'll come back to you with this discussion on this quantity, which is the discriminant of the quadratic equation, and this determines the nature of the roots of the quadratic equation. So just give me attention. So you just saw that if we write these expressions in the solution form using the formula method, then we have our x as x is minus b plus minus under root b square minus 4ac upon 2a. This quantity is called discriminant of a quadratic equation, and it is represented by discriminant. it is represented by capital B or delta. This D is B square minus 4AC. Since in this equation you know that the A, B, C are all real numbers, therefore this B square minus 4AC, because B into B the B square, so B square will be a real number, this is also a real number, and now here you have to put this inside this, and you know that square root of negative of a square root is called the complex number. A square root of negative thing gives you minus 1 if I say iota. Then it means that if you want to find the real solution of this quadratic equation, then the quantity b square minus 4ac should be always greater than or equal to 0. So now here we get, and then we say that suppose b square minus 4ac is greater than or equal to 0. So this is the condition. Then here you find that this one gives you the two ideas. Then either b square minus 4ac equal to 0 or b square minus 4ac greater than 0. If b square minus 4ac is equal to 0, then you see that this part simply vanishes and you will get the value of x as only minus b over 2a, and that is the case of the equal roots, because you are getting only one value, both the roots will be minus b over 2a minus b over 2a, because a quadratic equation always gives you two roots. So this is called equal roots, case of equal roots and real. So this is real and equal roots. When b square minus 4ac greater than 0, then you get different positive and values for this or negative value. Then after solving this, you get the two values of roots, and that is one is minus b plus under root b square minus 4ac over 2a, and another one is minus b under root b square minus 4ac over 2a, and this we call it as alpha beta. Distinct roots means real and unequal roots. Unequal roots also called as real and distinct roots. Distinct because they are different. If you have b square minus 4ac less than 0, then you get complex roots. You will get complex roots or imaginary roots. Imaginary roots. And now here one thing it has been found, that if b square minus 4ac is a rational number like the b, a, c, and these are the rational numbers, so the b square minus 4ac, if it gives you a perfect square, then you will find a different value of roots. But that is not a special case. Some authors write, I don't see that is a special case. So this is all about the discriminant of the roots. And now we try to find out what do the quadratic equation generally represent graphically. So now here we have a special case. Like suppose instead of using this equation, suppose if I have y is equal to x square plus bx plus c, then what will be the nature of this function, because we can call it as function also. Fx is y and that is ax square plus bx plus c, then how it looks like and what does everything represent. So we'll simply go and we'll try to solve this with the help of the idea that I have taken this one as a common, then I'll go by ax square plus b by ax plus c. So here a, I can write this as x plus b upon 2a whole square. So just like in the previous case, I have included this b square by 4 square, that b square over 4a square positive inside this. Then I have to make b square over 4a square negative inside this to compensate. So this one gives you x square this 2ab 2 times this into this, so 2 cancel, it gives you the bx by a, this quantity. Now after expanding you get the third term as b square over 4a square, and this is also b square over 4a square, so these two cancel, so you get only these two terms. Now I just try to keep this aside in this form, so I get a x plus b upon 2a whole square. If I multiply this with this, then it will become 4a. So I'll write it as c over, oh sorry, c minus b square over 4a. And if you want to write it as x plus b upon 2a whole square, then this minus, if you write here minus, then you get b square minus 4ac upon 4a. It will become like this. So this is what we are getting. Now if I try to find out what does this all represent, so for that you have to go to the notion of parabola. Like suppose if this you have y equal to just x square. If you try to find what actually it is, this is your graph. Sorry. This is the graph of y equal to x square. Now, if I just write as y equal to 2x square, this will flatten like this. This will become like this. So, this goes like this. If I make it y equal to half a square, or then the curve squeezes and it looks like this. So this is called the normal. And now we are going to discuss about the transformation of axis. So if you plot, suppose that I have a graph y equal to x square. This is my y equal to x square. So y equal to x square. Suppose if I have to plot y is x minus a whole square, or y is x plus a whole square. So my graph here, in this case, it will translate on the left side, and this will become like this. This vertex becomes a, sorry, this is for plus a, minus a comma 0. If you use this plus, then this will come here. So this is y is x plus a whole square. So it will shift minus a point just like that. And if you have this minus, then this will shift at this point, and the vertex will come at point a comma 0. Now if you have another form, suppose if you have y equal to x square plus something, then your graph, this is, I'm writing this as the dotted line, this is my y equal to x square, and here it is plus a, it means the graph simply goes up, and this point is 0 comma a, like that. If you have y is x square minus a, then the graph, because this is dotted is the reference line, so the minus a, it will, sorry, not this one, then the minus a will become like this, and this value will become 0 comma minus a. Now if you have your graph as y equal to x square. This will be something like this. The vertex at 0, 0. Y axis is the axis of symmetry. But if you have y equal to minus x square, then the graph will simply flip. So this is y equal to minus x square. So this is how it goes, and now I need to clean my screen so that I can discuss the more graphical feature. Okay, our quadratic equation can be y equal to x square. Then its graph will be like this. And the vertex, this is 0, 0. So in this condition, you can see that the minimum value on the y-axis, this is y, is 0 and it is increasing. So the minimum value of this function is y 0 because after this value is increasing. Now when you have this y equal to minus x square, then the graph will just flip and it will become like this. And this is 0 and then this is minus 1. So if you go down along y-axis you get minus 2. So it is decreasing. So the 0 will become the maximum value of the expression. Now if you have y equal to x square plus a, so now see y equal to x square, this will be something like this, but this is plus a, so it will just go a point up. The graph will become like this, 0 comma a. If you use y equal to x square minus a, so suppose this red line is the original graph. So this red graph, this is my y equal to x square, and this above one, this one is y is x square plus a. If it is y is x square minus a, then your graph will go like this, and your vertex will come here at 0 comma minus a. This is next important point. By multiplying with the coefficients 1, 2, 3, 4, 5, 6 like that, your graph will only flatten. It will remain like this only, but it will flatten like this. If you multiply it with any number greater than 0 and less than 1, then the graph will just squeeze like this. So that is the case. Now when you add something plus a, the graph will go up. When you subtract this minus a, it will go down. When you use y is this x square minus a, like suppose if you have the last one, you can say if it is a negative one, like if y equal to x square, then your graph is this. This is my dotted original graph. If it is y equal to minus x square, it will flip like this. Okay, because minus x square means all the value of the x square which is eventually positive, but since there is a minus, so all the y value will be negative and the graph will go like this. So this is idea. So now here you see that if I have the graph like this, then what I will get, that my graph will go like this. This is y equal to a x plus b by 2a whole square. So this is plus, so it will translate this on negative side because it is plus, so it will move on this and it will come something like this. And this value is your vertex, which is minus b by 2a comma 0. But here we have negative value of something. So depending on what kind of number this whole expression gives you, the graph will either move up if this whole value is positive. So there is minus, then the graph will go like this. And This one goes like this. So this point will remain minus b by 2a, but this value will become this whole thing, b square minus 4ac upon 4a, and that is also negative. So I write negative here. Okay, but if this whole thing is negative, then the graph will move something like this, means up value. And in this condition, b square, this point can be written as minus b upon 2a, and this one will become b square minus 4ac upon 2a. Now see the situation. If you look at this one, so this graph is giving the case of equal roots because x-axis is just tangent at the vertex. This one gives you the case of equal roots. Both values of expression will be minus, roots will be minus b by 2a. Here you are getting two equal roots here, two equal roots, because this curve is cutting the graph at this point and at this point. So you are getting your answer. But this one is not cutting x-axis along. So this one is giving you imaginary roots. This is all about the graphical nature of quadratic equation. Thank you very much. Subscribe to our channel and enjoy.